We recently launched the Meridian Lite. Why did we do that? We have the Meridian. The Mosaic Meridian combines our Mosaic X camera with a high quality INS LiDAR system. The Meridian Lite uses the Mosaic 51 camera rather than the Mosaic X. The general purpose of the Meridian system is to combine our camera data with high quality LiDAR data. The Meridian uses the Mosaic X with a INS LiDAR system that allows you to create extremely high quality point clouds, colored point clouds, and panoramic images. This is really great for high volume, high speed captures. If you need to do lower speed captures, maybe in an urban environment, maybe you don't always need to colorize your point cloud, the Meridian Lite can give you substantial savings, and it can give you similar performance to the full Meridian system. The difference between them is that the Meridian Lite uses the Mosaic 51 camera with rolling shutter sensors, which at lower speeds can give you images that are nearly as good quality as the Mosaic X. They do not give you the absolute geometric accuracy of global shutter sensors, but moving at lower speeds, this is not a problem. If you're not colorizing your point clouds, it's not a problem. So for certain types of users, the Meridian Lite is a much more affordable system that can give results that are, in many cases, quite as good as the full Meridian system. Some of our customers are doing data collection that requires a fast turnaround time, in which case certain types of processing of the data are not necessary. So for example, colorizing a point cloud is good for certain types of viewers, certain types of stakeholders, but for other purposes, it's completely unnecessary. So when doing jobs that require a turnaround time of, hours or a day or two, it's possible to use the Meridian Lite to capture image data, LiDAR data, and come out with a high quality trajectory, high quality point cloud, and georeferenced panoramic images that have centimeter accuracy. The Mosaic Meridian system is quite modular. The camera and the LiDAR and INS system are decoupled from each other. They're completely integrated together, and the data is extremely precisely synchronized, but each of these subsystems can be used by themselves. So in certain cases, our customers want to capture LiDAR data and image data, but it might be the case that after capturing LiDAR data of a certain area, it is only necessary to capture image data. It's possible to switch off or remove the LiDAR and INS system completely and to use only the camera. You can also do it the other way around. You can not use the camera and you can use only the LiDAR INS. It's up to you. So in the geospatial world of LiDAR systems and mapping, you'll find all kinds of devices on the market, from really cheap handheld devices to systems that cost upwards of €1 million, dollars or more. And all of these systems have their place and their appropriate use cases. But it is often the case that someone thinks that they need something more than what they do. So the purpose of capturing LiDAR data is typically to extract features and assets that need to be audited, recorded, mapped, and so on. You want to record, you want to extract this data from a point cloud. You want to figure out what it is and where it is. And you need to choose your device based on what you actually need. So if you're mapping all of the utility poles in a certain region, you want to be sure that you can recognize all of them, and you want to be sure that you know where they are exactly. But it might not be the case that you need to know where they are within 1 or 2 millimeters. And you might not need to know their size within 1 or 2 millimeters. That level of information and detail is often completely unnecessary, and it can be the case that someone might pay 10 times more for a system that can do that. The system will end up capturing a tremendous amount of extremely accurate data, but at a great cost, both in terms of the purchase price, the usage of the software, the operations of it, and the ultimate volume of data that is collected. So we've designed the Meridian to meet somewhere in the middle. It's not a cheap device that gives a very rough point cloud with very inaccurate results. It gives extremely accurate results. It gives you extremely dense point clouds, but not at the massive expense of systems that deliver an incredible density and accuracy of data that in most cases is unnecessary. So we have plenty of customers who are extracting all types of urban assets, telecommunications assets, such as utility poles, street lights, features on the streets, and the point clouds that the Meridian delivers are absolutely sufficient quality for that. And we have not found any customers who came back and said that the level of detail was not enough or they weren't able to extract the features that they needed. In every case, it has been more than enough density, quality, and accuracy. You can think of the ISP as one of the three critical parts of a digital camera or digital imaging system. You have the lens, you have the sensor, and you have the ISP. The lens, you know what that is. The image sensor, you know what that is. The ISP is what the raw image data from the image sensor goes into, and it turns this data into a beautiful color image. Before you put the data through the ISP, you have a raw image that is basically monochrome, and you have the pixel data from the sensor, which is red, green, and blue, and it does not exist as a color image. There are a bunch of complex operations that have to be done to this data in order to turn it into a color image, and every digital camera does this. It does the white balance, it does the debayering, which turns the monochrome image into a color image. It does all kinds of noise reduction. It does things relating to contrast, tone mapping, color science, color balancing. It does lots of things, and the process of tuning an ISP is necessary for any digital camera that captures not raw but color. So you have an H.264 or JPEG or whatever color file that you have. In the Mosaic camera, we have recently improved our ISP tuning to give our cameras better color balancing, better contrast, and improved dynamic range across shadows and highlights. It's a challenge in mobile mapping to capture the full dynamic range of a scene because you often have shadows and bright objects or sunshine in the same scene. So it's always a big challenge to tune the image appropriately for this situation. It's a little bit different from regular cameras with a narrow angle that typically have they're pointing towards a certain region. We're doing 360-degree spherical image and we're capturing everything at once. So it's a bigger challenge to tune the image to behave and respond appropriately in these scenarios. Megapixels is the ultimate specification of cameras. When you're looking for cameras, you're always looking, how many megapixels is it? Of course, you want as much resolution as possible, and it's also kind of a open secret that this is a kind of an easy marketing term to mislead people by. You can buy phones with 200 megapixels. That's more megapixels than any professional camera. So what's really going on here? And is megapixels the end of the story? Of course it's not. So any sensor has a specific size and a specific number of megapixels. So you can say that the size of the sensor is really important. The sensor is divided into a bunch of pixels, and you want those pixels to be as large as possible to collect as much light as possible. That's why a professional camera is often like a full frame sensor, 24 by 36 millimeters, and a mobile phone might have a sensor that is a tiny fraction of that size. And the larger camera might have fewer megapixels than the phone, but it'll give you a picture that is much higher quality in every measurable way. So Of course, megapixels isn't the end of the story. Of course, in a perfect world, you can have both. And you can have both if you spend a lot of money on a gigantic camera with a gigantic sensor. But in reality, this is often not needed or not desired or not possible. So you have to balance the size of your device, the size of your lens with everything else. Of course, with a larger sensor, you need a larger lens. With the Mosaic cameras, we have chosen the sensor, the size of the sensor, and the lens very carefully to balance all these trade-offs. The Mosaic X uses a 1-inch 12 megapixel sensor. The pixels are pretty big. The lens has been chosen very carefully to match the sensor. Every pixel on the image is very sharp. It's free of vignetting, chromatic aberration, and other sort of defects that you might get if you don't choose your lens carefully. So megapixels aren't the whole story, but of course everyone wants resolution, everyone wants to see features and text that is a certain distance away, and of course the higher resolution you have, the better. But that resolution has to be backed up by the appropriate size pixels with the right kind of lens that can resolve those pixels on the sensor. Our cameras have 6 sensors. They're 12 megapixels each, and they're pointing in all directions. So they make a panorama. 6 times 12 is 72. We have a 72 megapixel image. The stitched image is a little bit more than that because of the way that you remap images into a sphere, and then you project that sphere onto a 2D surface like you do with the world map. Greenland looks bigger on a Mercator projection. It looks smaller on a Robinson or Mercator or equirectangular projection. There's different ways of projecting a sphere onto a surface. Generally, in 360-degree imaging, you use the equirectangular projection, which is 2 to 1. So it's 360 degrees across and 180 degrees up and down. That's the sphere. So the top and bottom of the equirectangular image are quite distorted because you're remap something that is straight down onto a kind of strip on the bottom. So the difference between the sensor resolution, which is 72 or 74 megapixels in our Mosaic 51 and Mosaic X cameras, that gets remapped into a 12K or 13.4K equirectangular image. So the numbers are similar, but not exactly the same due to the way that the images are remapped into the spherical equirectangular projection. Let's talk about calibration. We have cameras with 6 image sensors, and we are stitching them into a spherical image, or we are taking those pixels and coloring a point cloud with those pixels. So this requires a lot of very careful calibration. What does that mean? So each of the images in the camera see something around 120 by 90 degrees. They need to be kind of warped or stretched a bit so that they fit together exactly. This requires us to model the characteristics of the image as precisely as possible so that the images fit together exactly with a sub-pixel error. We also have to model the position of the cameras in space. So there's 5 cameras going around and 1 pointing up, and they occupy a position in space. And when we model this correctly, it allows us to project the pixels in 3D space onto the LiDAR point cloud with a very high level of accuracy, so that the points from the LiDAR correspond exactly to the appropriate point from the camera. We do this calibration in our lab here in Prague, the full optical intrinsic and extrinsic calibration, as well as the calibration from the cameras to the LiDAR. We have a fully automated process for stitching in our Mosaic processor software. After you are done mapping, collecting data with your camera, you go back to the office, you put your storage device, your USB stick from the camera into your computer, and you run Mosaic Processor. All you have to do is select the appropriate calibration file from the camera, click Stitch, and your images will be stitched at a very high speed. Our stitcher is very highly optimized for running on a GPU. So you can stitch the images at a very high frame rate and get the data very quickly. We have customers that are mapping areas that require extremely fast turnaround, such as post-disaster documentation jobs, where they need to get the data as quickly as possible to the appropriate stakeholders. Using our stitcher in the Mosaic processor allows you to stitch your images very quickly, very easily.